We're here at Blackett Lab at Imperial College London. We're going to meet Jess Wade, who is the head of the Women in Physics programme, and we're here to have a day full of science. We're here with Professor Steve Schwartz from the Imperial College to talk about physics and space. So, what is space physics?
Well, space physics is a very generic term that covers everything that one might do. In particular, it usually refers to things that you might do locally within the heliosphere, within the sun's environment that involve, in our case, sending out spacecraft to measure the local magnetic fields, to measure the accelerated charged particles, to watch activity from the sun that bursts off and comes hurtling toward the Earth, to land on a planet or a comet or something else and try to understand the kind of the makeup of that, the origin of that, how the whole system, solar system, both formed and operates now. So it's primarily an activity that is space-related within the influence of the sun.
Can you tell us about the Rosetta Project?
Sure. So the Rosetta Project was a very ambitious project to go and rendezvous with a comet. It's a picture of a comet in full flight, and most of you know what a comet looks like. It has a big, long tail, and you know that it comes in from a long way out and goes shooting back. And comets are really interesting because they only survive as comets as we know them for a short amount of time. They actually reside way out in the solar system, and every once in a while a gravitational perturbation knocks their positions out and they come whizzing by the sun. So they've been living there a long time, for the hundreds of million years that the solar system has been forming. So they're kind of primordial, primeval substance, so they tell us something about what the sun was made of. But we always see them when they're in full flight, we only see them from afar. Because they come in from such a long way, they're quite hard to actually get close to. And we can send satellites to the planets, but that's hard. Comets don't work that way. So Rosetta was a mission to go and actually rendezvous with a comet. The other problem with comets is that they don't have any very much mass. This comet 67P, Trium of Gerasimenko, is only 4 or 5 kilometers big. So you can't get captured by it. You have to basically sidle up alongside it and accompany it, and that requires a lot of very complicated orbits. So the idea was to go rendezvous with this comet while it was still quiet, and to follow it in as it is now becoming a bit more active. It's not a particularly active comet, not like how this comet was, but it is nonetheless an active comet. So the idea is to learn how that activity grows, to probe, because we're going to be there and can measure it, not only its evolution, but in detail what kinds of different particles are there in order to determine what this comet is actually made of. To look to see, for example, what kind of water there. Comets are mostly water ice with a bit of dust and other kind of stuff thrown in. So there was some suspicion that the Earth, which is more plentiful in water than it should be, must have got some extra water from somewhere. Well, we now know as a result of the Rosetta mission that water didn't come from these kinds of comets because it's the wrong kind of water. It doesn't have the same heavy water ratio as the water in the oceans. So there's an awful lot of then chemistry there. People are busy looking at the organic molecules that are there to see whether cometary primeval kind of material had the building blocks of life, so primordial molecules and amino acids. So there are a whole lot of really exciting reasons to go and follow a comet. It's a very challenging thing to do, even more challenging to try to land on it, because what happens when you land on it is it's got no gravity, so it tends to bounce off. And indeed, despite all of their efforts, the little feline lander did indeed bounce off. It bounced about 2 kilometers high off of this 4-kilometer object, but eventually came down to rest. And we're now waiting for it to maybe wake up. But in the meantime, all of the instruments on the orbiter are busy collecting information about the environment.
Thank you. This is Science Rocks.